So the next configuration is a balanced delta-delta circuit. So if we have this configuration with no line impedance, we can get directly the phase currents. So if you look at the circuit, voltage VAB just in parallel with this branch right here. So this is just VAB. So IAB is equivalent to VAB over Z delta. So similarly with IBC and ICA, you can get their values to this equation. Or you can relate the IAB to IBC and ICA. This example, we have a balanced delta connected load having an impedance of 20 minus J15 ohms. Is connected to a delta connected positive sequence generator having VAB is equal to 230 with angle 0 volts. So calculate the phase currents of the load and the line currents. So we have a Z delta equivalent to 20 minus J15, and we have VAB equals to 330 angle 0 volts. Configuration of this example is the same with this. So we can directly solve for phase currents. Phase current IAB equivalent to VAB over Z delta equivalent to 330 over 20 minus J15 is equal to 13.2 angle 36.87 amperes. If we have IAB, we can now get IBC and ICA. So IBC is equivalent to 13.2 with angle of, so since this is a negative sequence, the current IBC is lagging by 120 degrees from IAB. This is negative 83.13. And lastly, ICA is 13.2 with angle of 156.87. So you have now the values of phase currents. So if you have the values of the phase currents, you can relate them with the line currents. So the line current IAA equivalent to square root of 3 IAB, and you subtract the angle by 30. This is equivalent to, we have 22.86 angle of 6.27 degrees amperes. So if we have one line voltage, line current And now relate this line current to the other line currents. So IBB equivalent to 52.86 angle of 11313 years. Then ICC is equivalent to 22.86 at angle of 126.87. We have now our line currents. Now if you have line impedances in the lines, you have ZL is right here, right here. So we cannot directly use now this equation. And when we perform AVL this loop, there will be too many unknowns. So IA, IAB, and IB. So what we need to do is that we need to transform this circuit into pi. So the same with a delta connected load, we can transform a delta connected source to its equivalent Y connected source. So looking at this figure, we have a delta connected load. We have VAB, VBC, and VCA. We can convert them into a Y connected source. So we have VAN, VBN, and VCN. So its relationship is the same with a line voltage between a Y connected source. So you let this VAB equivalent to wait, let's have this magnitude VL equals 0. So let's consider a positive sequence. VL angle negative 120. And then this is VL angle 120. If you convert this delta connected source into Y, we use the relationship between a line voltage and a phase voltage. So a line voltage is equivalent to square root of 3 times V phase, and then you add the angle by 30. So in this case, in a delta connected source, the VAB, the line voltage is given, and we convert that into phase voltage. We have VL for square root of 3. You subtract the angle by 30. So for this case, VAN equivalent to VAB over square root of 3 plus 30, or equivalent to VL over square root of 3 angle of negative 30. And this BN equivalent to ABC over square root of 3 subtract the angle by 30. We have VL over square root of 3 angle of negative 150. And lastly, VCN equivalent to VCA over square root of 3. Subtract the angle by 30. Have VL over square root of 3 angle of 90. So the last configuration is a delta to Y circuit. So we learned how to transform this delta connected source into a Y connected source. So having this configuration, we can uh, convert this into a Y source and then perform per phase analysis. For this example, we have a balanced Y connected load with a phase impedance of 40 plus J25 ohms is supplied by a balanced positive sequence delta connected source with a line voltage of 210 volts. Calculate the phase currents. Then use VAB as a reference. So we have VAB as our reference. We have 210 angle 0 volts. And then we have uh, ZY per phase 40 plus J25 ohms. Now to solve this problem, find the phase currents. We need to convert this delta connected source to a Y connected source. So if you have VAB equals to 210 angle 0, the phase voltage VAN is equivalent to 110 over square root of 3, and then you subtract the angle by 30. So we have this is AN, this is VAN, and we have our phase impedance. This is 40 plus J25. So solving for IAA, have IAA equivalent to VAN over 40 plus J25, which is equivalent to, we have 2.37 angle of negative 62.00 degrees amperes. This is IAA. So in a Y connected source, in a Y connected load, or in Y connection, the line current is equivalent to the the phase current. So we have our answer for IAA. Then we have IBB is equivalent to 2.57 the angle of negative 1 178.00 years, and ICC equivalent to 2.57 angle of 58 amperes. So here is the summary for the phase voltages and currents and line voltages currents for the four configurations. So remember, lowercase means the source side or the generator side, and uppercase means at the load side.